And a warm welcome back to Northampton College. I'm James and this is our Scania 113 to 143 V8 conversion. And today we're going to look at the starter motor. So we've got a couple of little challenges today with the starter motor. One, the wiring for the 6-cylinder was on the left hand side of the chassis, and the starter motor wiring for the V8 is on the right hand side of the chassis. So we're going to need to move the wiring around, and then we're left with a little starter issue. So once we'd built the thing up, occasionally it just wouldn't start, wouldn't send power down to the starter motor. So we're going to have a look at our starter motor relay. So sit back and enjoy this episode. Okay, so we're just going to have a look under this little cover flap there, and it's just to close off the electrics. You can see the sensors from the top of the gearbox down to the back end here. We've got enough play in the existing wiring that we didn't need to extend it in any way. Usual typical wiring condition of its age, where the cover, the conduit, if you want to call it that, is started to deteriorate, but the wiring's in good shape. So luckily we didn't have to do anything with the gearbox wiring. Covers off, we can have a quick look at this tail shaft. We call that in Australia. In England we call that a propeller shaft, so a prop shaft. Had to have that remade. You can see there it's got a double skin on it, thick skin and substantial welding. So you want a decent size prop with a torque from a V8. So that was made up because, of course, moving the gearbox forward, we needed to find a propeller shaft, a tail shaft for a single drive. So you weren't going to find that in Australia because I've not been able to find a single drive V8. So it's about getting one manufactured. So starter motor for the 6-cylinder. Now the problem is the starter motor on the 6-cylinder is there, and the starter motor for the V8 is there. When we get asked in class, what is the purpose, what is the point of a relay, I always start with where we was with old technology, because technology is a story, isn't it? It's where we was, where we are, and what the future looks like. So when I was an apprentice, we did a lot of restoration work on old Aston Martins, old Jaguars, that sort of thing. A lot of these cars didn't have starter relays. So they were running power straight from the battery, obviously via a fuse, and going through a starter switch or an ignition switch down to a starter solenoid. So you can imagine the amps that were being pulled across the contacts in that starter or ignition switch. So we're going to do some measurements shortly just to back up some theory. It's always good in a training environment when you can show the theory but also back it up with fact, do a practical demonstration. So we're going to do both of those shortly. But if we had a look here at the Scania system, this is what we're pretty much faced with. Still a very simple system, but you're now got a fuse box after the battery. You would have a fuse box anyway, a pre-relay car. It was all fused. You'll go into an ignition switch, and then your ignition switch sends a voltage down to pin 85, our DIN number 85. Remember those DIN numbers we've spoken about before. When there's a voltage at 85 on the relay, that will go across to 86, which is ground, of course, via the little winding in between 85 and 86. So once current is flowing between 85 and 86, there's a magnetic field that's generated. When that magnetic field is generated, pins 30 and 87 become connected via that switch, because the switch is pulled down through the magnetism of that field between 85 and 86. So we're going to prove all this later, and we always do it in a college environment, so you guys who are watching can do these little tests as well at home. So we're going to prove that the relay works. And when we say it works, just from an audible perspective, we're not going to power anything up. We're just going to hear it click and then look on a multimeter to see how many amps it's pulling. So that's our later system from a Scania. And this is what we had to do. We had to find out why we had an intermittent non-start after we'd wired it up, and it made perfect sense because the starter motor solenoid was dangling, if you like. The starter motor was just dangling in the chassis, where the piston of the 113 6-cylinder came out the side and it broke the starter motor, and now you've got this wiring, this heavy live just dangling in the chassis. So people had got in it after the accident and tried to start it, and of course the live going to the solenoid would have been touching the chassis and pull excessive current across pins 30 and 87, damaging the internals. When we pulled the relay out, and you can even see in the picture there, the relay's distorted, and the little Bakelite plastic plates where the pins are, that had all heavy black carbon from the excessive arcing. So that poor device would have been glowing whilst the wiring had sat in the chassis, making that permanent connection to ground.
So what we're going to do now is do some measuring of our relay. So let's first have a look at the connections that we're going to measure. So if we go and draw our relay, so we've got terminal 30 there, that's going to be our permanent live. We've got terminal 87, this will go down to our starter motor. Okay, so we're going to call that our starter motor. This is our winding, and we've got terminal 85 and 86. Now, when there's current flowing through 85 and 86, you get a magnetic field on this winding. That will then pull this switch down in the relay. So what we're doing is we're using a small current to switch a large current. Okay, now if we look on our relay, it says 70 amps. So we've got a 70 amp relay here. All right, now, how do we know we're going to use a small current to switch a large current? Well, we're going to do some maths. So I'm going to measure the resistance between terminals 85 and 86. So we set our meter to ohms because that's a unit of measurement for resistance. And then we come across to 85 and 86. And you can see there I've got about 162 ohms. Okay, so I'm going to write that down. So we've got 162 ohms. This is a 24 volt relay, and we can prove that because on the side there it tells you it's 24 volts and it's got a capacity of 70 amps. So there's a safe capacity of 70 amps that can be switched between terminals 30 and 87. But I'm going to prove to you now by doing some basic math that we only need a small current to switch a large current, and that's why the terminals 30 and 87 are big wide pins for heavier current, and terminals 85 and 86 are small because they don't carry much current at all. So let's do some basic math. So 24 divided by 162. Let's get our calculator out. There we go. So that's how much current will be pulled across terminals 85 and 86. So I'm going to prove that to you later on. We'll just go down in the workshop and I'll show you how you can use the multimeter set to amps and safely test for the relay to click. So it's just an audible test, but it can help you if you're in that kind of side of the road scenario. So just by putting power to 85 and 86, a live and a negative, it will power up this winding, and it will generate a magnetic field that will then pull down that connection, and you will hear a click every time there's power flowing through. And you'll also see on the screen what number we get. So we want to remember this number, 0.148 of an amp. So if we can get something close to that, then we know that 1, the formula works, and 2, we know that the measurement we made, the theory behind it, is accurate to how many amps that it should pull. What I'm going to do here is just show you how to test a starter relay. So if we looked at DIN numbers 85 and 86, so 85 will be your crank signal from your ignition switch, 86 would be the ground. So between those two contacts there's a winding, so when I put a small amount of current through, that will generate a magnetic field across 85 and 86. Then what will happen is when that magnetic field is present, it will pull the switch down, which will send power from 30, which is your battery feed, down to 87, which is your starter motor solenoid. So that's how we can use a small current across these little connections to switch a large current. Now when I did the calculation in the classroom, we see that it would pull something like 0.14, 0.15 of an amp. So let's prove that. Let's actually see if that's real. So firstly, what we're going to do is I'm going to get my live down to my meter, and I've got to set my meter onto amps, because this will not only give you a fused bit of wire going through the meter, so it's great for testing low current draw devices. So if you put your red lead into the 10 amp port and your black lead into the COM port, and then switch your meter set to amps, okay, not milliamps but amps, you'll then get 10 amps capacity to test something. So the good thing about this is I'll not only get a fused piece of wire to bridge something out, but I can also look at the visual reading there, so to confirm that something is working. So we're listening for that audible click for the switch between terminals 30 and 87. So I'm going to put 86, which is the ground of the winding, on the ground there, and I've got my black lead coming from the COM port is going to send live down to pin 85. So when I touch that, I should hear a click. Hey. So you get that audible click, so you know terminals 30 and 87 are switching, but also look at the amp reading, 0.15. And my calculation earlier was 0.143. So there you go. It works, the formula works. So we know that's how to test our relay. Yeah, so the starter motor for the V8 is on this side, and I had to extend the wiring from the left side to the right side, but also I had to make sure that the gauge of the wiring was the same from the 6-cylinder to the V8, because if you haven't got the right thickness of wire, it won't carry the same amount of amps. So we made sure that all the gauge of wiring was the same.
Hope you enjoyed the video. Don't forget to like, subscribe and share. Team 143 guys, let's do this, and we'll see you on the next one.